Hello, PascoMath grade 8 teachers. Today we're going to look at 8.EE.2.6, unpack the standard a little bit, and look at what you could be doing in the classroom, as well as what students should be doing to show mastery of the standard, and anticipate some misconceptions and talk about how we can address those and use them for learning. So let's go ahead and get started. So the standard itself says, use similar triangles to explain why the slope m is the same between any two distinct points on a non-vertical line in the coordinate plane. Derive the equation y equals mx for a line through the origin, and y equals mx plus b for a line intercepting the vertical axis at b. So when we unpack that a little bit, students are going to gain some additional knowledge about slope in the standard as they use similar triangles to explain how the slope of m of a line is the same between any 2 points on a non-vertical line. Students also understand positive, negative slopes, zero slope, and undefined slopes. And then through the use of similar triangles, teachers can leave students to derive the general equation y equals mx plus b and discover that m is the slope and b is the y-intercept. So now let's talk about what the teacher could be doing for the standard. And so first is just facilitate some class discussion about two similar triangles. And so they have some background knowledge from grade 7 about similar figures, similar triangles in particular as well. And so we can use that, leverage that coherence piece to prior knowledge for the standard. So we need to create those similar triangles first, though, so we just need to pick some points. I'm going to pick this one. And let's go. Let's go. So we got triangle there. Had to go up 3 over 1. Maybe pick up here. There I had to rise 9 and go over run 3. And so you can have some conversation around these two similar figures. Have students connect their language, the precise math language. Again, when we say up, that's loose language. We want to say, the rise. We rose 3, and the run was 1. The rise was 9. The run was 3. And have them connect, like, are those create similar triangles? Like, how do you know? Is the relationship, are these equivalent if we put them into ratio form? Are they equivalent ratios? Or rise to run for 3 over 1, is that equivalent to 9 over 3? And so have that conversation with them. Challenge students to find the slope of horizontal lines and vertical lines and explain the reasoning. Even have them create some similar triangles on their own from a line and see it doesn't matter which points. Like, did I just magically pick these points and it worked? Or if I picked a point way down here, would it have still worked? Could I have went up 6 and over 2? Would that still have worked? And so just allowing the students to explore a little bit. Demonstrate how to find the slope using the formula. This isn't something they just magically know, and so this is something that they would have to. Of course, we want to make sense of it through these contexts, but then also show them the formula, and give them practice with that, and lead students to discover the equation y equals mx for a line that goes through the origin, and y equals mx plus b for a line that goes through point B. So when looking at what the students should be doing for this standard, they need to be able to explain orally and in writing using similar triangles why the slope of a line is the same between any 2 points on a non-vertical line. A great opportunity for math practice 3 and 6. They also need to discover that b is the y-intercept and m is the slope in the general equation for a line, y equals mx plus b. Determine the slope of a line from a graph table or linear equation, and then explain orally and or in writing how proportional relationships, lines, and linear equations are related. Right there looks like a great writing prompt for me in the classroom. For them, you really get at the student understanding and thinking there. I am going to pop out of this real quick to show you, though, this part. Discover that b is the y-intercept and m is the slope of the general equation of a line, y equals mx plus b. See just a quick teaching tip on how you can implement that in the classroom. And so I'm just going to pop over the Desmos. And so when you are on, I'm just going to go from the start so you see how it works. So we pop in the Desmos, and you can type in that general equation, y, just on the keyboard, y equals mx plus b. And it's going to ask you for sliders, and the answer is always yes. And so we have some sliders that are just put in there. So right away, you can see that it is using m equals 1, b equals 1, and graph that line, y equals 1x plus 1. And I want to actually focus just on that y equals mx, that proportional relationship first. So I'm going to set b equals 0, so I just slid it over. I'm going to turn on the projector mode so you can see the line better too. And so the cool part is now that we have the sliders going, you can do something as simple as hit play. And we can really just say like, all right, we're trying to explore like what does m do to this equation? Like this is m equals 1, and this is what it looks like. And you can hit play. I'm going to slow it down a little bit. And so after I hit play, we can see, okay, m is getting smaller. And okay, something definitely happened there. Now m is negative, but getting smaller, but this thing's getting steeper. And so then having the students explore all the different cases of like, what does m actually do to the graph? And then students will say, well, at that midway point, it's like getting a flat, and they might use that language, or you're like, yes, horizontal, and trying to connect that precise language. And we can even talk about like, well, you can stop at any point. Like when m is 0, what is happening here? When m is increasing and it's positive, what's happening? When m is decreasing, what's happening? And kind of a lot of good conversation around steepness, and connect that back to slope and rate of change, and all those math vocabulary words can be coming out here. Once students discover that m is the slope and how that affects the graph, we can dive in. I'm going to just set m equal to 1. That way we can dive into b and see what b does. And so students can explore. I just have play, just spark some interest. If they have devices, they could do this on iPads even. And again, have them start to discover, like, pause at key points and like look, like, all right, this is -1. Well, I see a 1 here, but it's positive, and this is -1 in the graph, but that's -2. And so I have the students try to figure out like, what is this -1, and put it up as it was going, like, here's 3. And once they have some conjectures, like moving around, see if their conjecture still is valid or not. So like, B is 3, so how does this 3 relate? So that's -1, that's -3 there. Does that have anything to do with it? Or here's Y is 3 here. Does that have anything to do with it? Well, let's move it to 4, and so forth. And see if they can figure out, like, if we change the slope, what's staying constant? So even at that, they could start to discover. So it's just a nice exploratory way for them to make sense of y equals mx plus b. So I just want to take the opportunity to share that with you. So let me pop back into PowerPoint real quick. So addressing misconceptions, a common error. Students might misuse the formula for finding the slope of a line given 2 points. They might use x minus y and not keep the coordinates in a consistent order. For finding rise over run, they might do run over rise and things like that. So use these errors as a springboard for your instruction. So when you do have 2 separate answers, that should be like music to your ears. Like, all right, so 1/4 of the class has this as an answer, 3/4 of the class has this. Why did you get this? How could you get that? And really use leverage that for student learning in the classroom for sure. That's it for this standard. If you have any questions, feel free to contact me or your regional specialist, and thank you for making PascoMath more awesome.